Jean Courriage. Global warming. Something our grandparents didn't really think about, and a big problem for the furry bears at the bottom of the world.
Stop!
I'm here today to find out if heat pumps really will put polar bears back at the top of the world. Let's go in, shall we? Today we'll be embarking on an energizing adventure to discover the world of heat pumps. I'm going to be discussing this with my fellow heat pump enthusiasts and my doctor friends. Maybe they can tell me what this red patch is on my back. Hello again. Here we are joined with experts, Dr. Dave and Dr. John. Dr. Dave, you look rather buried in work right now.
Yes, me and the heat pump both actually. You see, heat pumps transfer from areas that are cold to areas that are hot, which is the opposite direction of natural heat flow. And to do this backward transfer requires a work input. You can think of heat flow like walking up and down a hill. Going up the hill is tiring and takes effort, whereas the downward journey is pretty effortless. Ground source heat pumps are stored on the ground, so I guess you could say the system is pretty buried in work right now.
So I do work too. Does the ground source heat pump work at 9 till 5?
It surely does work 9 to 5, but maybe not in the way you'd think. Work done is all about energy transfer for a specific distance, and in our case just concerns extracting heat from the ground or the air. We call this environmental energy. This, along with a small amount of electricity, can provide heating and hot water to a building.
Well, that's all well and good, but I still don't understand how these systems actually work.
A generic heat pump has four main components: an evaporator, a compressor, a condenser, and an expansion valve. It also uses a refrigerant to aid the heat transfer cycle, which has some fancy properties which we can discuss in person later if you're interested. But the general premise is the evaporator, which takes environmental energy from somewhere like the air or the ground and moves it from outside to inside of a heat exchanger and then onto the refrigerant, which will evaporate into a gas. The compressor takes the refrigerant, which is compressed, to increase the temperature. The condenser is where heat transfer takes place and goes to a heating system where the refrigerant goes back into a liquid. This heat will then be supplied to the building through a chosen method like radiators or underfloor heating. The expansion valve is where the refrigerant temperature decreases so that the cycle can then be repeated.
Wow, that's some great stuff. I've heard about the efficiencies of these things. What sort of numbers are we talking?
About 400%. Yes, 400. There's this thing called COP, which stands for Coefficient of Performance. It's a ratio between useful heating or cooling to the energy required to power the system. With heat pumps, they convert work to heat. This alone is a COP of 1, which means 100% efficiency. They also pump additional heat, which can make the COP value increase to 4. In other words, 400% efficiency. And I think remembering this with a police analogy works quite well. So, the larger the COP, the better the COP is at fighting crime, making his work easier and more efficient.
Who knew the police were saving us so much energy, hey? Final question. Why should we swap these out for our boilers?
I can give you 3 great reasons. Your operating costs in the long run will reduce. You will reduce your carbon footprint and you'll even be ahead of the curve for the future of heating. There are some great schemes out there to help reduce some of the initial costs of the heat pump, and the government have even introduced 0% VAT on installation.
We've learned a lot so far. Heat pumps do more work than me, and they do it all backwards. They evaporate, compress, condense, and expand. Virtual shapeshifters. They're even more efficient than my dad putting up IKEA furniture. Hope you learned a bunch. See ya!